So let's try and make a graph of log base 2x. So this is kind of like your parent graph for this. So I want to do it through way of a table. So the big idea here is to choose your x's. Should I have an apostrophe s there? X's? English people? Yes? No? No? It's just, that's going to look weird if I just do x's. Anyway, you got to choose your x's wisely. Okay? So again, we want to know what exponent takes me from 2 to whatever my x is. So let's just write that in. What exponent makes 2 into the x we choose? That's a question. Okay? So let's make a little table here. And on this side, we want the value for log 2x, just like we've been kind of hampering on, right? Because this is our f of x piece, right? So what's a nice one? Let's start with an easy one. Let's choose 1 for our log. Okay? So it's like these are the actual values of this, right? This is f of x. So if I'm going to make this whole value equal to 1, what x did I have to put in? Nope. If I want to make f of x, hold it. If I want to make this number right here, f of x equal 1,
Zero.
what does this x have to be?
Zero.
If this is the exponent, 1,
Oh.
what number do I get when I take 2 to that number?
Two.
2. Okay? So over here, let's make a graph. Make it big. I don't want like these little these little miniature graphs that we can't label anything on later on. Okay? So here's x, and this is going to be the height of my graph is f of x is equal to log base 2x. This is really the only confusing part about this. Okay? Like you guys just went through a whole bunch of exercises on how to do the logs, but now you've kind of got to think in reverse, right? So this is a point on my graph. When I put 2 in, so this is still the x, right? This is my ordered pair. The ordered pair that I get from this is 2, 1. So let's put it on. 2 and 1. Okay? Let's make the log or the exponent, right? This means exponent. Yeah? Let's make that log or exponent equal to 2. What x would I have inputted in to get that 2 out?
4.
4. Let's put that point down. 2, 4. So that's a good one. And these are getting easy now, right? So let's do another one that's easy. So let's put 3 in. 8. Okay, so this is the exponent, right? If I put 8 here for x, the exponent that takes me from 2 to 8 is 3, right? That's the output. That's the ordered pair. So I'm generating ordered pairs, but I've got to be smart about which x's I choose, right? They have to be multiples of 2. Okay? Let's write that over here someplace. Multiples of 2. Okay? Let's go the other one. Well, here, let's graph that one. Well, that's kind of a crappy place to put that. it's going to be way out here, right? Halfway, maybe like there. 8 is going to be 3 high, right? So you can see the shape of this, it's kind of flattening out, right? If I go to 16 next, way out here, that would give me 4, right? And if I went out to 32, that would get me 5. So I'm getting a lot longer along the x-axis as I'm going up just 1 unit at a time on y. Does that make sense? Look, I'm going up every time I do another multiple of 2, 2, 4, 8. I'm just going to be moving 1 up on the log. So it's like I'm going through this really slow, but I just want you to be able to see what the shape of every log is going to be and how it works. Okay? Let's try, what happens if I put this here? What does that get me? Does this work? Yeah? If my exponent is 0, 2 to the 0 gives me 1, right? So this is kind of an important point because if we don't have a constant in front, it really doesn't much matter what my base is here, right? This is going to be, when I put 0 in for an exponent, I'm going to get 1 out. So whether my base is 2, 4, 6, 38, 42, okay, okay, I'm always going to get that 1, 0 point coming out, right? Okay. Can I choose any other numbers in here? Like what? What x's are still going to complete my graph? So I'd say a half. A half is perfect because it's still a multiple of 2, right? Okay. What exponent did I use to get there? -1, right?
1/4.
Okay. Yep. So let's just go one at a time here. So if I put a half in, that's here, right? That's going to get me my -1. I go half of that is a fourth, which is, I heard there. What's that going to get me? -2. Okay, so that's going to put me like here someplace, right? Okay, I think people kind of see what's going on here. What kind of number can I not have here? You could have 150. It would just be a decimal, right? It would be ugly for us to graph. But I mean, which one is impossible? Like a negative number, right? If I put -1 in here, that's undefined. These numbers on this side of the graph are off limits, right? What about, I kind of ran out of space. I thought I planned this properly. Here, let's sneak this in here. What about 0? Can I make 2 into 0 by way of an exponent? No, you can't. So that one is off limits as well. Sorry, I sneak that one in there. That, like, I wrote that small, but it's kind of an important one. Okay? So here, let's do this. What's the, can I move this up just a little bit? Oh, you're very smart. Here, what is the domain of my graph? Looks like
0 to infinity, but 0 is not included.
0 is not included, right? Looks like I've got x has to be greater than 0, right? What about the range?
Numbers.
Yeah. Looks like all real numbers. And Ben brought up a nice little idea there. What's going on here? I think it was Ben. What happens here? There's an asymptote. There's an asymptote of, what's the name of that line? What's the equation? Ooh. Y equals 0, x equals 0. X equals 0, right? Okay? So I don't know. There it is. There's your logarithm, right? So that's the idea when you graph it. So it's just, like, I did this really slow, but the ideas, the big ideas are here. If we're talking about kind of that anchor point, It's this. It's a lot like an exponential equation in that our anchor point isn't really on the graph. Now check this out. If I did this, right, I've got that 0, 1 point. 1 goes in, 2 comes out, 2 goes in, 4, or negative 2 goes in, 4 comes out. These are positive, right? Think of it in the other direction. Okay, positive 1, 2, positive 2, 4, positive 3, 8, right? I've got what kind of relationship between a logarithm and an exponential do I have?
They both have
There's the word. They are inverse. Okay, exactly. Okay, so let's just for fun, I'm going to do this in a different color. Okay, but if I go and draw the graph 2 to the x is equal to f of x on here now. Okay, our simple exponential that we did from last class, or the last little bit, right? Okay, here's my anchor point. 1 goes in, 2 comes out, 2 goes in, 8 comes out. I'm going to end up with this picture, right? Where y is equal to x is my axis of symmetry. Okay? These two graphs are inverses. Okay, so we're going to get to this a little bit more next class. I want you to concentrate on these tables today, but just keep in your back pocket the idea that logs are inverse to exponential curves. All right, we'll stop there and do some practice.